So I thought to order to kind of clear things up a little bit, I would distinguish between what we call cold clouds, cool clouds, and warm clouds. And we've talked recently about the Bergeron process. Let me see, where's my thing? And so I want to make these three types of clouds. This will be my cold cloud. This will be my cool cloud. These are all what cumulus clouds, aren't they? And this will be my warm cloud. Okay. And we talked about the Bergeron process. A cold cloud, basically, you have the Bergeron process going on, which of course is the formation of snow or ice crystals. My little X's means solid, solid water or ice crystals. Within cold clouds, you have the Bergeron process going on throughout the cloud, and it will fall from the base of the cloud as snow. In a cool cloud, of course, the upper elevations will be colder, so the upper part of the cloud, we again have the Bergeron process, but at some point we reach temperatures warmer than freezing, and these are my little liquid water droplets. And we're going to talk more about something called the collision and coalescence process, and that's kind of what can kick in when we have liquid water falling through a cloud. So this actually, even though it starts out as snow with the Bergeron process, it's going to fall from the base of the cloud as liquid rain. This last one over here, you got it. Warm clouds, even at the upper part of the cloud, all we have is the temperatures are such that you're going to have liquid rain droplets forming at the top. And of course, it's going to fall from the base of the cloud as rain. Okay, so that's kind of the difference between cold, cool, and warm clouds. So focusing on cold clouds, so I'm going to show you 4 scenarios, and we're going to get different precipitation at the ground, but it's all going to start out with, remember these little X's are my snow crystals, with the Bergeron process. Bergeron process. Okay. So notice it falls from the base of this cold cloud as snow. But at some point, because remember that we said that, well, I guess one way to look at it, as you get closer to the Earth's surface in the troposphere, it gets warmer, doesn't it, in general? Okay, we said as you go up in the troposphere, it gets cooler in general. So the cute little snow crystals melt here. They go from a solid to being a liquid, and of course we call this precipitation rain. So over here, this is looking at the temperature of the atmosphere, and the way you look at this is over here in the blue area, water would be a solid because it's freezing, and over here in the pink area, water would be a liquid. So just kind of showing you the profile temperature of the atmosphere. You can see this is kind of the tipping point where water goes from being ice crystals to being liquid for rain. Okay, so that should be refreshing to know that even if sometimes we get rain, it starts out as snow. For those of you snow lovers out there. So now here's the second of 4 scenarios, and as you might imagine, down here in the middle section, there's no melting. Okay, it's a cold cloud. We have the Bergeron process going on up here, and actually then temperatures here don't get to warm enough to melt that snow. So hey, we get snow. Okay, so not so surprising, its temperature profile here, all of the snow or solid, all of the ice crystals, everything's over here in the blue area. So now we have two more scenarios, those being sleet and freezing rain, and they both go together, and I'll show you how that works. Both sleet and freezing rain, sometimes this makes it as a test question, both of these events involve what we call a temperature inversion. And you had this term actually, I don't know if it was chapter 4 or chapter 5, but what a temperature inversion is basically at some point as you're going up in the elevation of the troposphere, the temperatures get warmer for some region, and that temperature inversion actually gives us these two things I'm going to show you, the sleet and the freezing rain. Alright, so let's look for our temperature inversion. So here we have the Bergeron process going on. Okay, notice that as the snow falls, it leaves the cloud. It is still cooler than the freezing point temperature. But here is our elevation, which the temperature is warmer than is warmer than the melting temperature of water. So it goes ahead and liquefies. So it's a solid, then it's a liquid here. Okay. So it's falling as rain right there. Now, at some point, we have kind of a pocket of air that is colder now. It's for some reason, as we got near the troposphere, the temperatures got colder again. That's what we call a temperature inversion. And the consequence of that is to go ahead and take that liquid and to refreeze it. But we can't have the Bergeron process going on right here with that falling precipitation. The Bergeron process can only go on up here. So it doesn't like reorganize itself back into those cute little snowflakes. Instead, you get these pellets. Actually, not necessarily. Depending upon how far it has to go ahead and fall, you'll get pellets. Now, in this case, it had enough room to fall to go ahead and give you what I'm calling right now pellets of frozen precipitation we call sleet. So notice how it went from a solid from the Bergeron process. It warmed up and it became a liquid, rain basically, right? And then it refroze, but we don't get the Bergeron process down here. Basically, we just get little pieces of ice. Okay, we call this sleet. Okay. If we were to look at the temperature profile, remember when you look at this, that anything in the blue area, water is going to be a solid. Anything in the pink area, water is going to be a liquid. So in this scenario, we've got this sort of thing. It goes from a solid to a liquid. Notice the liquid's warming, and then right here begins your temperature inversion, right here. And then it goes ahead and it, instead of warming as it falls to the ground, we hit a colder pocket of air, and the liquid is cooling here, and the liquid is freezing here. Now this depth right here, we're going to see that it, like I think I said just a minute ago, there was enough time for that rain to go ahead and refreeze in the form of sleet. I don't know how to, I don't have a thing to draw. My X's are snowflakes and my circles are liquid. Okay, I guess I could kind of make them, this is my sleet. Okay, so the last one I want to talk about here actually involves a temperature inversion too, and it's freezing rain. So let's look for the temperature inversion. We have the Bergeron process going on in this cold cloud, and the cold cloud, it will be such that even from the base of the cloud we get snow. Now within the troposphere, we know that as you head towards the ground under normal conditions, temperatures get warmer, so we go ahead and temperatures got warmer. It goes ahead and it liquefies. This is like the rain portion. Okay. So it rains clear down to this point. Now the difference between this slide and the last slide, I don't know if you'll catch this, I bet you will, is that it goes ahead and it was a liquid closer to the Earth's surface. Okay, notice that this is a shallow temperature inversion. It's not as deep. And so even though we have freezing conditions down here, temperatures that are cooler than the freezing point of water, there's not enough time necessarily to form those sleet particles. And so it freezes on contact. It's what we call freezing rain. Your textbook calls it glaze. I would call it freezing rain. So let's look at the temperature profile and look for the temperature inversion. So this is the normal warming of air as you're getting close to the Earth's surface. Okay, and then this would be the temperature inversion, where as you're getting closer to the Earth's surface, it's getting cooler. Okay, and then this right here is that shallow region near the Earth's surface where the water refreezes. But again, there's not, if you go back and forth between this slide and the last slide, there's not as much time here when the temperatures are cooler than freezing for it to go ahead and form those little sleet pellets.